So now we do the most simple and the most fast version of 3D character controller in Unity. First thing we do, we jump right into. First thing we do, we create a capsule character with eyes. So we put another cube so we see where it's rotated, because we'll be adding rotation as well as movement, and as well as we will apply rotation to the motion vector, to the direction we're moving to. Yeah, so we create capsule, we create box, we make sure we add. I'll just remove these components, so you do the same thing. You add character controller, it's built in Unity, it's standard, so you just add it. You don't edit anything here, you just add another thing you do. You create C# script, I just did it, call it simple player or something like that. I call it simple player or simple character. We open it, it's start and update basic, and we jump right into coding stuff. It's pretty simple. It will be moving like in a moment or so. One thing I see is the collider was a little bit down. I see it, so it's not correct. The collider of character controller, because character controller is inherited from a class named collider, so it has its own collider. And I have to move it a little bit up. I just know the value because I did it before. It has to work for you, or it can be fine already. So yeah, and now we have to create a private variable, character controller, to get a reference to this class. We call it character controller. It's a logical way. Let me see if I've added this script. I didn't. I have to add it. Simple control, simple player. Yeah. So now we have it on our capsule, on our character, and we have to get this component into this variable. So we do get component, character control. Yes. And now let's write movement. No, get inputs, input controls. First thing we do, we get input controls. What's pressed? What's player pressing? A, W, S, D. These buttons. Then will be done. Right now we create vector 3, which will be collecting our. We can just say collect input controls. We call it move. And it will be a new vector which will be getting each frame to see what is pressed and what is not pressed. We get on the axis we get input, get axis horizontal. It's AD buttons, X moving on X-axis, this part. We won't be moving on height on Y-axis for now, and on Z-axis it's front backwards, WS buttons. We get input, get axis vertical, And that's our collected input controls. This vector gets values from basically from 0 to 1. 0 means complete static, no movement, like here. And if we're not pressing anything, it will be 0 here and 0 here. If we're pressing, it will be closer to 1, close to 1 or 1 on this if we are pressing, for example, W, it's 1 here. If we press an S, it's -1 here, and same, if we press an A, it's -1, D, 1, like that. And here it's like W means 1, press W, pressed S means -1. Yeah, now we have to have some speed to control it and to move not super slowly but with some speed. So we create public variable, public float speed. We'll just make it 5, and it will be editable in editor, so we can change it anytime. So for now I write multiply by speed, which means or applied speed, because here we have the direction of moving basically, but we don't have speed applied. Here we just write move multiply equals speed, and now move vector is the speed is applied to move vector, and it's collected already the direction and the speed. And now we just have to write character controller move. Move is a function that is inside of built-in character controller. We don't have to do anything, we just have to give it this vector that we have to this function, and character controller will move the character accordingly. So we just write move and multiply it by time delta time, because we are why isn't it wrong vector 3, I guess. Vector 3 new vector 3 okay, vector 3. There are two different vector 3s. Unity is using Unity engine. It has to be Unity engine, yeah. So yeah, like that. So yeah, it's a bit of a mess. Now it works. If it was your problem as well, you can fix it like I just did. So yeah, it was a basic mistake of me clicking something earlier. Not on purpose. So right now it has to move correctly. We assign it to move function multiply by time delta time, because we are in update, so it has to be multiplied by that. And now we should be ready to go. We are moving perfectly fine, and if it's a simple game where we have to move a character by 2 axes and it has obstacles like these boxes, it collides, it's okay. And if we don't have to move upwards or jump, it's a perfectly good controller for our use. We can control speed, Right now we will apply like rotation, so it rotates to the direction where we're going. And let's test it on a like this slope, trying to get up and down, and we will see that we can perfectly fine like moving up, but when we try to go down we just fly. So we can go up but we can't slide down. Why is that? Because it's not a rigid body and it doesn't have any force applied to it, and of course it doesn't have gravity applied to it. Right now we will add like rotation, and we will add gravity to it, so we can slide down and fall if we like jump from here, so we can fall down, and that will be our controller. And in the next lesson we will add, in the next part of this lesson we will add in another video jumping, because it's a little bit more complicated than this. Right now just rotation and falling down with gravity. So to add rotation, it's actually added pretty simple. We write it here right after we calculated our final move vector. We write it like this. We check how big this vector is, if it's at least something, if it's bigger than smallest number, bigger than 0 basically. So we write it like this, move dot magnitude. It's like magnitude of the of this vector, how big it is, because if we have very low inputs, very low, like we shouldn't move. We can move, but there's no actual reason. And of course, if it's zero, that's the main reason why we're checking it. If there are no inputs at all, and if it's 0, it will be applying here. We will be applying this move direction. We will make our rotation same direction as our move vector, and if it's 0, it will be applying this rotation when we're not pressing anything to our character, and we don't need that. That's why we do this like checking. And here we just do a simple thing. We do transform forward, which is our blue like arrow, our forward direction, equals move. That's it. The direction we're moving into is the direction we're looking at. If we have no inputs, we don't do this. We don't need it, and it will be bad if we do this, because it will be unnatural. It will be rotating after we give up our inputs and don't press anything, and it's not good. So let's check. Our rotation should work pretty fine. Yeah, and it's doing really good. It's doing it even smooth, because we're doing get axis and not get axis raw, which would get like 0 and 1, and this one is pretty smooth. This one is pretty smooth, so it doesn't go from 0 to 1 in one moment. It has some like speeding time from 0 to 1, and it looks pretty good. The only thing we have to add now is gravity, so we fall down, and the gravity will be half of our work with jumping, because because if we have gravity, we only have to apply that jump force to it. So to add gravity, we have to add two new variables, two values. It's very important. So we add private float vertical velocity, which is basically, we'll put it 0 just to be clear. It will stay 0 like only for one frame, like 0 frame, and then it will be added. But to be clear, vertical velocity, which will basically be our vertical velocity, our y. Like we don't use y, it's always 0 in MoveVec. Multiplying by speed makes it 0 as well, so it never changes. But we need to change it with adding gravity. So we add this vertical velocity, we'll be counting it right here, add gravity. That's the moment, like the place where we'll be, like right here, we will be doing it. And before giving our move vector to move function, so character controller moves, we will be adding our y should be we will apply our vertical velocity to y on this. So it's just one line of code. It's move.y equals vertical velocity. That's it. So we have to count it here, and we have to apply it to move.y, and it will be perfectly fine. We will be counting our gravity, of course, in each frame. And first thing we're gonna do here is we're gonna write add gravity each frame, not just add or even increase gravity. What do I mean here? We do also we have to add second private float gravity value. We know it from physics, is 9.81 F. It doesn't have to be like that, we just use a standard value from the real world. It can be any number. Less it will be lower gravity, like higher it's just, you know, Earth's value of this gravity value, standard gravity value. So vertical velocity, I'll just write it and then I'll explain it. Vertical velocity has to be gravity value basic, not equals, but minus equals. So it's our velocity, so it changes. And if we're falling, for example, it increases. We don't just fall statically. It it gets bigger. We're falling with each second, millisecond. We're falling faster. So this one, when we are falling, and right now we're not falling, but if we are falling, this gravity value always increases. For now, we just do it increases always, and then we'll just make it 0 when we have to. So when we're not falling, we will make it 0, like right here. If not falling, basically on ground, standing on ground. Vertical velocity 0. That's will be here. But here we just do gravity value multiplied delta time, because we are in update. And let's see what this does along with this one. So it increases our gravity with each frame. We're not making it 0 anywhere, and let's just let us see what this does. So with each frame, on the frame 0 it will be 0, on frame 1 it will be like negative value, then it will be more negative, more. Right now we are falling, but with this value is always increasing, and every time we fall even faster, and it's gonna like go to crazy numbers in in minutes. It will be like huge numbers, and we don't need it to be increasing. We need it to when we touch ground, it has to be 0 and it has to stay that way. We're not moving anywhere. And when we fall, we want to like start slowly and like increase it all the time. So all we have to do is to make this thing I wrote here, like to code this thing. If we're not falling, standing on ground, we have to make this one 0. So for that to happen, we have to actually know if we are touching the ground. We don't have to calculate it by any way, because our character controller does it for us. We just create a Boolean variable, which is player grounded, something like that, equals character controller dot is grounded. Is grounded is variable of this class that basically like does the work inside of it and just tells us if we are touching ground or if we are not touching ground. So it is now stored in the beginning of every frame in this variable we created, and here we just check if player grounded, and second important part is this means we're standing on ground, and the second part means we're not falling. These are a little bit different things to check if we're not falling by our concept, by our idea. It's checking if vertical velocity, basically we're checking if we are falling actually. If we are falling at the moment, like if the velocity is negative, but we have already touched the ground, we have to make this velocity 0. So it's logical. If we were moving down with this, but have already touched the ground, we have to make it 0. So yeah, it's like that. Now we can check, and it's everything we needed, except for having jump. Like jump, it will be another much shorter video, because this one was very like a lot of explaining of basic things. This code is everything you basically need to make a simple controller, very practical controller without jump. But you can do like some pretty cool stuff with like this sliding off some cliffs and stuff, using these slides to go up and down. It's actually bouncing pretty cool when we are getting down. So yeah, it's a pretty, if we're making some maze game or stuff, we can use this controller. The thing that it doesn't have jump is not really a big problem. It's pretty simple and cute. So yeah, thanks. Give a like and some comments if you like it. I will gladly appreciate it big time. So yeah, have a good development.